Hi everybody. Today we're looking at the sum and product of the roots of a polynomial. Now, when we were talking about the fundamental theorem of algebra, we were talking about zeros because we were just talking about a polynomial. In this case, you'll notice that we're now talking about a polynomial equal to 0, and because we're solving a polynomial equal to 0, we talk about roots instead. You might say it sounds like a technicality, and let's be honest, it is a technicality. But it's just important why we're using different terms, because they actually mean slightly different things. Now, they've expressed their polynomial in this sum notation, but I want to express it in a slightly different notation. We're talking about a polynomial of degree n. So we're going to, the highest power of x will be x to the power of n, and we're calling the coefficient of that a with a subscript n. Okay, so that's the coefficient of x to the power of n. And if you look at their terms here, they've said that AR is a coefficient of x to the power of r. Now, the next one will be a to the n minus 1, and that will be the coefficient of x to the n minus 1. The third one will be a to the n minus 2, x to the power of n minus 2. And that will keep going down until we get a2 times x squared plus a1 times x to the power of 1 plus a0, where it's x to the power of 0. X to the power of 0 is 1, and so we don't show it. And it's all of that equal to 0. Now, the roots of that equation, or if you want to think about it another way, the solutions to that equation, if we find all the solutions to those equations and we add them up, we get this. We get minus a and minus 1. So we get this coefficient minus and divided by this coefficient here. That's what happens if we add them all up. Now, if we multiply them all, what happens in that case is we get this coefficient, and what I might do is instead of circling them, I might highlight them. So for the sum, we'll do the sum in yellow. So it's a to the n minus 1 divided by a to the n. And then we'll take, for the product, it's a0, so it's this one here, divided by a to the n, so the leading coefficient. So we call that the leading coefficient because it's the coefficient of the highest power of x, so we'll just write that there. So leading coefficient. And in that case, we also have this factor of minus 1 when it's an odd degree. So it'll be negative for odd degrees. Remember that n is the highest power of x, and that's our degree. And then it'll be even, rather positive, for even degrees. Okay, all right. So, the roots of a cubic are x1, x2, x3. Without solving the equation, find the sum. Okay, let's write it out. 3x cubed plus 5x squared plus 2x take 4 equals 0. Now, to find the sum, it was the coefficient, it was the negative of the next coefficient n. So we've got the leading term with the leading coefficient, and then you take the next term on, you take its coefficient. That's the one we want. So if we write the formula, it'll be negative a2 on a3. So it will be this one here, the one term in from the leading term, divided by the 3 there. So the sum will be negative 5 on 3. The product, well, that will be minus 1 to the power of 3. Remember, for odd it will be negative. And then it was a0, so it's the term on its own without an x. So that's negative 4. You've got to take the sign in front. You can't just take the number. And then we divide it by the leading coefficient, so dividing that by 3. Okay, Alright, now negative 1 to the power of 3 is negative 1, so it'll be negative 1 times negative 4 on 3, which gives me 4 on 3. And then finally C, that's not the sum or the multiplication. So let's think about it. 1 on x1, x2, plus 1 on x1, x3, plus 1 on x2, x3. Well, if I multiply this one by x3 on x3, this one by x2 on x2, this one by x1 on x1, what I'll get is I'll get a common denominator, which will be the multiplication of all of my roots. And then what will I get in the top line? Well, I'll get x3 from that term. I'll get x2 from the middle term. I'll get x1. And look at that. What do you know? You get the sum on the top and the multiplication of roots on the bottom. We've found both of those. So the sum is negative 5 on 3. The multiplication is positive 4 on 3. When you have one fraction over another with the same denominator, those denominators cancel. And so we get left with minus 5 on 4. Okay, alright. Now, second example, find the sum and the product of the zeros of the following polynomials. Okay. Now, first of all, we've got a quartic. X to the 4, I'm going to write it with its coefficients. So 1x to the 4 plus 1x to the 3, take 2x squared plus 3x, take 2. For the sum, it'll be this one and this one. Those are the only two that we're worried about. So the sum will be minus 1 from the x cubed term on 1. So it'll just be minus 1. The product will be minus 1 to the power of 4. Now a0 is down here, that's take 2. 1 is our leading coefficient, that gets used again, so it'll be minus 2 all over 1. Now minus 1 to the power of 4 is just going to be positive 1, so I don't need to worry about it. That's just going to leave me with minus 2 over 1, which is just minus 2. Okay, alright. Number B. 2x to the 5, take 5x to the 4. Technically, because we're talking about roots, I should say that's equal to 0. Plus 15x cubed, take 511x squared, take 4x plus 8. Now, if you think about it, if we're doing sum and product, all of those in there are irrelevant. They don't matter. Sure, they're part of the polynomial, but they don't matter to us for what we're doing here. Maybe instead of erasing them, I should put them in a red bracket to say they're irrelevant. Okay, so what are we looking at for the sum? We're looking at this minus 5 and the 2. So the sum will be the negative of negative 5 divided by 2, which is 5 on 2. The product will be minus 1 to the power of 5, the positive 8 there, all over the leading coefficient of 2. Now that minus 1 to the power of 5 is going to be negative, so it's going to be negative 8 on 2, which is negative 4. Okay, and then last one. Now, this one will trick some students up. So it's minus 5, x to the power of 2019. And then we've got plus 7 x to the, what was it, 1457. Now let's take 4x to the power of, if my memory serves me, it's x to the 250. Take 15x to the power of 47 plus 21. Now for sum and product of roots, the only terms that concern us are the leading term, the constant term for a product, and for a sum we also need the next term in from the leading term. So that will be x to the power of 2018, not the 7. Okay, that power is a long way down. It's a long way from this x to the power of 2019, because all the terms in between it are 0, but we need to just add one of those in to help us remember it. So the sum, well, I use this coefficient and this coefficient, so it's minus 0 on minus 5, which is just 0, so the sum will be 0. The product, well, it'll be minus 1 to the power of 2019 times by 21 over minus 5. Now, minus 1 to the power of 2019 will just be minus 1. It'll be over minus 5. The negatives will cancel and we'll be left with 21 on 5. Okay, and that concludes sum and product of roots.